Okay, so now that after talking about the impacts of the increasing greenhouse gases, we said there were three main parameters that all the models agree on: temperature, precipitation changes, and sea level rise. Now let's talk a little bit about how these three parameters will impact our lives. And we can talk about how they're going to impact our health, our agriculture, forests, water resources, coastal communities, biodiversity, habitats. Nearly everything we can think about related to our lives are going to be impacted by climate change, and we can focus really on these three parameters of temperature, increasing temperature, increasing sea level, and changes in precipitation. So first of all, if we look at health, obviously we're going to see changes in weather-related mortality. If we're talking about heat waves, floods, people impacted directly, infectious diseases, things like malaria, which is affected by the climate, the temperature, rainfall patterns, air quality, and how this affects health, respiratory illnesses, both from air pollution in the atmosphere, particles from forest fires, many areas which will affect our health. Talking about agriculture, the yields of crops are going to be affected by droughts, about heat waves, the amount of rainfall, the changes in rainfall, how much irrigation we're going to need to grow our crops and to feed the people on the planet. Plants and livestock are also going to suffer from various diseases, which may be new invasive species related to changes in the climate. If we look at forests, where can forests actually grow? Different types of trees may have to be transplanted because they can't adapt to the high temperatures or the changes in rainfall. What will be the geographic range of forests and the health of the forest fires, various pests which are going to maybe damage the forests, the productivity of the forests, water resources, the amount of water that we'll get in certain locations, both for drinking and for irrigation, the quality of the water, competition between countries for water. If we have lack of water, there may be actually conflicts which may be driven by water due to climate change. If we look at the coastal regions, we just spoke about rising sea levels. Well, erosion of beaches, of cliffs and we know a large fraction of the world population lives along the coastlines. Inundation of coastlines due to flooding, both rising sea level, but also storms that we have, which will increase the flooding along coastal regions. We're going to have to invest in a huge amount of infrastructures, maybe to protect our coasts and to keep them from being flooded. So huge implications on coastal regions due to climate change. And finally, if we look also at the natural systems, biodiversity, ecological systems, different species of plants and animals, there may be a huge loss of habitats due to changes in the climate, a loss of species, changes, say, in the cryosphere also, which will reduce the amount of glaciers, water resources. So as you can see, just these three parameters are going to have a huge impact on our lives in any way we look at it. Let's take one example of how changes in the temperature can affect, say, heat waves. Well, if we look at this distribution of temperatures, say the temperature in Tel Aviv, we have an average temperature, we have some cold days, we have some warm days. And if we shift this just by a few degrees, we're talking about global warming of 1, 2, 3 degrees, we shift the average temperature, what we see is we may not notice this change in the mean, but we start to get many more hot days and much more frequent hot weather. And we also have in the red extreme days where we have temperatures above anything we've seen before, much less extremes in the colder side of the spectrum. So this is if we shift the mean slightly towards the right. Another possibility is let's change the shape of the curve, and this may be more relevant for the rainfall, where if we have the average rainfall may stay the same, but we get much more rainfall in some places, much less rainfall in other places, and we change the shape of this distribution, what we call the standard deviation. So we get a lot more variability in this parameter. And we can most probably have both of these together, shift the mean and change the shape of the curve and the standard deviation. And again, if we're looking at, say, temperature, we'll have many more hot days than we had in the present climate, many more heat waves and record temperatures, but we can see that we still may have a few cold days even in a warmer climate. And so if we have a very strong snowstorm in the winter in the US or Europe, doesn't mean that we don't have global warming. We're still going to have a few cold events and some cold winters, but overall we're going to have many, many more warmer days and record-breaking days on the warmer side of the distribution. Here we can actually see an animation of the actual observations, what's happened since the 1950s on global temperatures. So the mean we can see for the 1950s, we have warmer temperatures to the right, we have colder temperatures to the left. And if we look, we're now in the 1980s and we're moving to the 2000s, and you'll see that this distribution starts to shift more and more to the warmer temperatures to the right-hand side, having more warmer temperatures, more peak and record-breaking temperatures, and less record-breaking cold temperatures. So this is happening, and it's going to continue to happen as we move into the future. If we look at, again, using the scenarios into the future from the IPCC reports, the left we can see the distribution of global temperatures between 2020 and 2029, compared what we'll see at the end of the century for the low greenhouse gas scenario on the top, an intermediate scenario, and the high emission scenario at the bottom. And again, we see that the distribution keeps shifting towards the warmer temperatures and also changes the shape. On the right-hand side, again, we can see the distribution, the spatial distribution of these temperatures for a 1.5 degree warming, 2, 3, and 4 degree warming of the planet. And again, if we look at the statistics of these hot, record-breaking temperatures, the extreme temperatures, again, we can break this up as, let's take the past climate from 1850 to 1900, and we use an event which only occurs once every decade as our baseline. And then we see how often do those events of that magnitude happen when we've warmed the planet to today's levels of, say, 1 degree warming. And we see that this occurs now 2.8 times every decade. And as we go to 1.5, 2, and 4 degrees, by the time we get to 4 degree warming, nearly every year, 9.4 years out of 10, will have these record-breaking temperatures. And at the bottom, again, we see the intensity of the record-breaking temperature. We don't just break the record, but we have much higher temperatures as we go to a larger global warming. So when we can see that a 1 degree global warming, the heat waves or the extreme temperatures will be maybe 1.2 degrees warmer than the previous record breakers. When we get to a 4 degree global warming, we can see that these records are broken by 5 degrees above the normal temperatures. Now, a very interesting example to show how this impacts humanity is the heat wave and drought which occurred in Europe in 2003, the summer of 2003. What we see here in the green curve is the distribution of temperatures, summer temperatures in Switzerland from 1863 to 2003. The red line shows the average temperature in the summer of 2003. This was about a 5.4 degree warming for the summer. For places in the Mediterranean, this still would have been a fairly pleasant summer, less than 23 degrees, the average temperature. But if we look at what happened in Europe there was an excess of 70,000 people that died because of this heat wave in only 11 days. On the left, you can actually see the excess mortality number. If we look at how many people died above the normal time for that year, you can see it's normally around about 0 if it's the average for a year. But in this 10-day period, this peak we can see here, when you add up all the people that died within this 10-day period of the heat wave, there were more than 70,000 people in Europe which died, mainly elderly people and children, people with respiratory problems because of air pollution. On the right, you can see the map in the reds where we had the maximum warming. So it's mainly in France, but also Italy, Spain, the UK. And this mega heat wave had a huge impact on society. In 2022, we also saw a huge heat wave in England with also maybe not as many people died because people have already started to adapt. But for example, in England, only about 10% of the houses and families have air conditioners at home because they don't expect such hot temperatures, whereas in Israel, 90% of the homes have air conditioners. So we need to adapt to these climate changes in the future if we want to deal with them. If we don't adapt to them, we're going to see mortality rates go up, whether it's from heat waves, from air pollution, from fires, from flooding, and from many other impacts of the climate change. Another large impact we're seeing is the wildfires, especially in places like Portugal, California. Here we can see the wildfires in the US overall, but they're mainly in the western part of the US. Both the number of wildfires has been increasing in the last decades. Also, the acres burnt, the area burnt, which represents how dry the vegetation is also increasing over time. And obviously the damage done, the dollar damage at the bottom by these wildfires is increasing dramatically. So the changes in the climate is having a dramatic impact on the economy in places like California because of the number of fires, which is burning down houses and towns, but also causing a lot of health problems to the public because of high levels of air pollution. And if we look at just one industry, the coffee industry, and we all like to drink our coffee, is going to also be impacted directly by climate change. And a lot of the coffee is grown in tropical regions in developing countries, which will maybe suffer the most from climate change. When we're looking at Mexico, Colombia, Brazil, Tanzania, Ethiopia, Vietnam, all of these are major coffee growers. And you can read by yourselves that the climate change, whether it's changes in temperature, changes in precipitation, is going to have a dramatic impact on the coffee industry in these parts of the world. This is going to have a direct impact on the economies of these countries, and it's also going to have a direct impact on the price of coffee that we're going to have to pay for if we want to drink our espresso in 2060. And finally, an area which is close to my heart and my research related to natural disasters, specifically related to the weather, whether we're talking about thunderstorms, tornadoes, hurricanes, flash floods. If we look at the statistics and how these have changed, and we're talking about the big events where we have to bring in the United Nations and aid agencies to help different countries, we had about 200 of these big natural disasters in 1980, and this has increased by a factor of 4 to more than 800 by 2020. And if we look at the different colors on this plot, the earthquakes, which we call geophysical natural disasters, earthquakes, volcanic eruptions, have not changed over this period as we would expect. There's no reason for them to have increased in frequency, but the meteorological events, the hydrological events, the storms, tropical storms, these have increased dramatically in the last decades and have contributed to this rise of a factor of 400% increase in the number of these natural disasters that we're seeing around the planet. And as we go into the future, these are going to increase, and for every half a degree warming that we increase to warm the planet, we're going to see more and more of these natural disasters with direct impacts on mortality and on the economies of countries around the world.